The people of the Kalahari hold the future to genomic medicine. It promises personalised medical treatment based on your own DNA sequence. The key to unlocking this potential lies in going back to the source, the original bedrock of genes that make us human. Even if you've never been to Africa, on a genetic level, you never really left. When it comes to the origins of humanity, this is where we all come from. As a genomicist, Vanessa Hayes maps our DNA in the search for our common ancestry. Last year, Catalyst travelled with her on a road trip across Namibia in southern Africa. Our mission traced the roots of humanity's family tree.
You know what is the body?
Yes, of course.
That's all totally the real life of a human being.
Exactly.
We met people with the greatest genetic diversity in the world.
They have more variety in their DNA sequence than, say, you and me, who's from European ancestry.
We're revisiting this story because what she found could redefine our knowledge of human history. Vanessa's mobile DNA lab collected blood samples from 3 different tribal groups.
He likes the colour difference between our skins.
The lifestyles of these groups reflect the dramatic transition that led to the birth of modern society, from nomadic hunter-gatherers to settled farmers. In the Kalahari Desert, San people gather food from the bush and hunt for meat, with survival skills that are almost superhuman. In the harshly beautiful Namib Desert, Khoi people also live off the land, but herd livestock as well.
Gewoonlijk is het net van wetmense bloed wat die medisyne gemaakt wordt, zoals ik verstaan het. Nou is het ook onze bloed wat gevat wordt en onze bloed wat gaan getoetst wordt en die medisyne gemaakt wordt. Dan zal ons ook nou biggie. Daarom is ik biggie blij en trots op haar.
In central Namibia, the agricultural townships of Herero people grow crops and farm cattle for meat and milk.
En je ma? Herero. Pa Herero.
Maar je zei pijs was dater.
Pa dater.
Vanessa wants to read the human history written in the genes of Southern Africans. But more than that, their unique diversity provides the entire library of genetic information that keeps humans healthy.
We study disease at the genetic level. We're always mapping DNA, especially since the new technology wave. We are sequencing sick people over and over and over. The problem is, what defines sick if we don't know what is healthy?
Nearly a year later, we've caught up with Vanessa in Sydney to find out what she discovered in the blood samples from Namibia.
What we've done is we've had a look at their mitochondrial genomes and how their genomes fit into the tree of life. And that has been exciting.
Mitochondrial DNA, inherited through the mother's line, is isolated from white blood cells.
So we make more DNA of the maternal genome, and then we sequence it. So that means we'll read every single letter that makes up 16,500 plus bases.
One of the questions she sought to answer was how people in the Kalahari are related to those living in the Namib Desert.
We weren't sure what the relationship was going to be between the hunter-gatherers, or the San people, and the herder-gatherers, the Khoi people. And what we did find is actually no linkage in their maternal genome between the San hunter-gatherers and the Khoi herder-gatherers.
This comes as some surprise because up to now, anthropologists and linguists linked the ancestry of Khoi and San people through their language.
They both have clicking languages, and hence they've been grouped together. But yes, their DNA is telling us a different story. It tells us still that Khoi and San people represent our early modern human lineages. Both of them do. But it appears that we should probably unlikely use the word Khoisan anymore, because it's like calling everyone Eurasian all the time instead of European and Asian. And there is a huge amount of differences between Khoi people and San people in their genetic makeup. This is the first time that we've actually got the genetic evidence that they are of two distinct lineages of people.
She says she's not scared because she's a woman, she's had 3 children. Okay,
It adds another branch to the family tree and takes us closer to its roots. The maternal genome is like a molecular clock, a time machine that takes us to the deep past, right back to the origin of modern humans.
The reason we've actually focused on the maternal genome first, we've done this deliberately because our interest is to tell timelines. So timelines of human origins and timelines of human divergence.
The big news is that it looks like they've shed new light on the age of our origins. Previously, her team has dated the San genetic heritage back to 172,000 years, the oldest known human lineage.
What we actually have been able to do now by including more people with these ancient lineages, we are able to redefine the time that modern humans came about. And we keep on pushing that time actually further and further back, past the 200,000 years.
You're now past 200,000 years.
Correct.
So how far back are we going with the information you have now?
I'm not sure I should tell you that.
I think you should.
No, I don't think I should.
It's a momentous discovery that rewrites human history, but Vanessa's reluctant to say more until the results are published.
Every time we go back to Namibia, go back to the region, we add more and more genomes to the tree.
It's okay?
And actually, every time we add more genomes, it's telling us that it's more diverse than we ever knew.
As new individuals are added to her database, her team finds new branches to our family tree.
Well done, and go for it.
One of those individuals is the Archbishop Desmond Tutu. When we first sequenced him, and he became the first African to have his human genome sequenced, we had no idea, and he had no idea himself, that he would be carrying an incredibly ancient maternal lineage.
Archbishop Tutu's support for Vanessa's work opened the door to African communities.
Our database has just exploded with genetic information by bringing back DNA from people that represent our earlier divergence. The reason for that is the DNA from a Kusan person or from a person living in Southern Africa is way more varied than a genome from a person living in Australia. And what that provides for us is an information data set of variation that just naturally occurs in modern humans, what our bodies can tolerate as diversity.
This is where the importance of this research to genomic medicine comes in, say, for diabetes.
If we understand what was our baseline and we can mirror that baseline genome of what we are like as hunter-gatherers and how many of the indigenous cultures struggle with diabetes, we will start understanding the disease.
It's going to make a huge difference when you can have medication specifically tailored for particular people.
The success of this medical future depends on ensuring all populations are included, especially the oldest and most diverse human genomes from Africa. Here in Australia, genomic information about Aboriginal people is growing. Until recently, much came from just one lock of century-old hair in a collection at Cambridge University. Now new research has sequenced the genomes of more than 80 individuals.
What it actually shows is that Aboriginal Australians represent a different wave out of Africa, a much earlier survival out of Africa. And I think that this is critical to understand human longevity and how we survive. I think it's significant that a population can leave Africa around 70,000 years ago, migrate all the way to the other end of the globe, and still survive today. This tells us a lot about being modern human and about survival.
Vanessa hopes to do the kind of genomic work she does in Africa with Aboriginal people in Australia.
If Indigenous people are not included in databases, just talking to companies that generate drugs, almost 80% of all the drugs that they are generating, they will first go back to the human genome and have a look. And if every population group is not included in those databases, we do not know if those drugs are suitable for those populations. Now, what is so fantastic with working with the Indigenous people in Southern Africa is they probably understand better than anyone else where they actually come from, where we all come from.
That's so good om je te sien. Hey, jy lyk jonk, man.
And they will compare us to the baobab tree that you see in Namibia, where the upside-down tree, where the roots look like they're out the ground. And they will say, we down at that big trunk level, we've always been there. And all the rest of the world comes out to the top of the baobab tree.